Hi everyone. Remember last time we talked about multiplying radical expressions? Today we're going to talk about dividing radical expressions. But our main focus for today is going to be to do something called rationalizing the denominator. So when we divide radical expressions, which is one of our objectives today, sometimes we have to rationalize the denominator. And let's look at what that actually is. So let's do some review first. Do you remember, back when we started learning about radical expressions, we wanted to get our radical expressions in simplest form. So there were three requirements for this. The first one was that the radicand, or the thing under the square root sign, had no perfect square factors other than 1. So this one was perfect square. And it also, the radicand, so the thing under the square root sign, also had no fractions. So we didn't want to end up with any fractions in our square root sign. And the third requirement was that there were no square roots in any denominator. So this is square roots. So that's what we're going to be focusing on today. Oftentimes, when you divide radical expressions, you end up with a square root in the denominator. So the way to get rid of that, and the way to put it in simplest form, is to rationalize the denominator. So to get rid of that square root, we will rationalize the denominator. Rationalize the denominator. All right, let's look at how we're actually going to do that, and then we'll do some examples. All right, let's go over some steps for how we're actually going to rationalize the denominator, and then we'll try some examples. So our first step, when we're given one of these problems, is to simplify if possible. This will make our life a little bit easier. So simplify if we can. Then the second step is really where we're going to rationalize. So the second step has us multiplying the whole expression by a form of 1. Using the square root in the denominator. So that's probably a new term we haven't heard before, a form of 1. So let's think about what that might be. Well, we know anything divided by itself equals 1, right? Like let's do, 3 divided by 3. 3 goes into 3 one time, so this equals 1. So we could hypothetically do this with square roots, like square root of 2 divided by square root of 2 equals 1. So we're going to multiply our radical expressions by something like this. And it won't change the expression at all because we're really just multiplying by 1. We'll see what that looks like. The third step is to simplify again, if necessary. So simplify, because we always want our end result to be in simplest form. All right, let's do some examples. All right, our first example is square root of 7 over square root of 2. So we're going to solve this using those steps we just outlined, and I put them right here in very simple terms. First step is to simplify if we can. This is already simplified as much as we can, so we have to go on to step number 2. We have to multiply by a form of 1 using the square root in the denominator. So I'm going to multiply this whole thing by square root 2 over square root 2. I'm not changing this problem at all because I'm really just multiplying by 1. So if I do this, I get the square root of 7 times the square root of 2 divided by the square root of 2 times square root of 2. Now this, I can use the product property on, so I'm going to make these into one big square root. So I'll get square root of 7 times 2 over square root of 2 times 2. And if I multiply these out, I get the square root of 14 over the square root of 4. And we know the square root of 4 is 2. So this equals, in the end, square root of 14 over 2. Now, let's look at our third step. That's to simplify again if we can. But we can't because square root of 14 is as simple as it gets, and 2 is not a square root. So we're all set in our simplest form, and this is our final answer. Let's do another. Okay, example number 2 says the square root of 3 over the square root of 8n. So we're going to follow our steps. Our first step is to simplify, and we can simplify here because 8n can be reduced. So let's rewrite this. I'm going to rewrite this as the square root of 3 over the square root of 4 times 2n, because 4 is a perfect square. Now I can separate these using my product property into square root of 4 times square root of 2n, and what I'm going to get is the square root of 3 over 2 square root 2n. Now we're in simplest form for now. We need to get rid of that square root in the denominator, so we're going to follow the second step. We're going to multiply by a form of 1 using that square root in the denominator. So I'm going to multiply top and bottom by the square root of 2n. So 2n over square root of 2n. And I'll see that I get square root of 3 times square root of 2n over 2 square root of 2n times square root of 2n. And I can rewrite these using my product property, so I'll combine them into one big square root on top, 3 times 2n over 2 square root 2n times 2n. And I can rewrite this again when I multiply things out, so I'll get square root of 6n over 2 square root of 4n squared. Now the bottom, I can use this as a perfect square. So 4n squared, let's see here, I'm going to get square root of 6n over 2 times 2n. That's the square root of 4n squared. So finally, let's see what we got here. Square root of 6n over 4n when I multiply things. And this, if I follow step 3 and simplify again, can't simplify any further. So this is my final answer. Okay, our third example is square root of 2x over the square root of 24x. So our first step is to simplify. I can simplify here since 24x can be broken down. So let's rewrite this as the square root of 2x over the square root of 4 times 6x. You always want to break these up into something with a perfect square if you can. So 4 is my perfect square. I can break those two up using our product property. And I'm going to get square root of 2x over 2 square root of 6x. I'll leave you to check that by yourself, but let's move on. So our second step here is to multiply by a form of 1. So I'm going to use that square root of 6x in the denominator, and I'm going to multiply top and bottom by the square root of 6x. And I'll see that I get the square root of 2x times the square root of 6x over 2 square root 6x times square root 6x. Okay, let's rewrite this again, all with our product property, putting these together. So I'll get square root of 2x times 6x over 2 square root 6x times 6x. By now you might be able to see a pattern. This part in the bottom here is always going to be factored out into just one of these. And what I mean by that is I'm going to get, if I rewrite this again, all multiplied out, the top is going to be 12x squared, and the bottom is going to be 2 square root of 36x squared. So if I do the square root of 36x squared, I'm going to get 6x. So let's rewrite this down here. I have the square root of 12x squared, and on the bottom I have 2 times 6x. See that there? Comes right out. All right, now let's rewrite this with multiplication. So square root of 12x squared over 12x. And now let's move on to that third step. Third step is to simplify again if we can. Up until now we haven't been able to, but here I think we can. That top, square root of 12x squared, that can be factored into something further. So let's rewrite it down here, and I'm going to pull a